After this lesson, students should be able to rearrange algebraic expressions and evaluate algebraic expressions. Let's take an example here. Example is that rearrange an expression 3y power 5 minus 5 plus 4y cube minus y power 4 in two ways. Number one, in ascending order. Ascending order means lower degree term to higher degree term. Number one and number two. In descending order. Descending order. And also we are going to calculate the value of expression at y is equal to 2. So these are the three questions we are going to answer now. Let's get started with the answer. Solution. The given expression is what? Given expression is 3y power 5 minus 5 plus 4y3 minus y power 4. We know that this is first term, second term, third term, fourth term. So what is the degree of this term? The degree of this term is 5. The exponent of the variable is the degree. Constant term always has the degree equal to 0. 4y cube, what is the exponent of the variable? 3. So the degree of this term is 3. And the last term has a degree of 4. If we want to rearrange this, of course, then the rearrangement would be 0 will come first. So in ascending order, so we are going to write the lowest degree term, which is minus 5, and then 3, for which the corresponding term is 4y cube, and then minus y4, and then plus 3 y power 5. So minus 5 plus 4 y cube minus y power 4 and plus 3 y power 5. This is from lowest degree term to the higher degree term. We just look at the exponents. The exponents must be increasing from lowest to higher. And in descending order, this is exactly the opposite. So this would be 3y power 5 minus y power 4 plus 4y power 3 minus 5. So this is the descending order. And if we want to find out the value of expression, that is, wherever we see y, we are going to replace y with its value, which is 2. So instead of y, we are going to replace with its value, and this value of expression at y is equal to 2 is what? 3 times, instead of y, it must be 2 power 5 minus 5 plus 4 time, wherever y is, we are going to write down 2 power 3. Remember that we use bracket when there is a number outside. So to make it clear that 4 is multiplying with 2 power 3 minus 2 power 4. If we want to calculate this, its value, this would be 3 times 2 power 5 is equal to what? 2 power 5 is 32, because 2 times 2 times 2 times 2 times 2. If 2 is multiplying with itself 5 times, that should be equal to 32. Minus 5 plus 4, and 2 power 3 means 2 times 2 times 2, which is equal to 8, minus 2 power 4 means 2 times 2 times 2 times 2, like 2 is multiplying with itself 4 times, which is equal to 16. So 32 3 times is 3 2 times is 6, and then 9 minus 5 plus 32 minus 16, and you can find out whatever the answer is. And now let's do another question, and in this question we have that rearrange the expression for z power 4 plus 81 plus 32 over z4 minus 1 over z square plus 9z square in ascending and descending order. In ascending and descending order. So let's again rewrite or find out what is the 4z4 plus 81 plus 32 over z4 minus 1 over z square plus 9z square. What is the degree of this term here? The degree is equal to 4 here, because the 4 is the exponent here. And like already has been told, that the constant term which does not have any variable, its degree is always equal to 0. So this has 0 degree. And if the variable is in the denominator, what is its exponent? 4, then its degree would be equal to minus 4. Because if we take z power 4 in the numerator, it will change the sign of the exponent, which will become z power minus 4. Therefore, the degree of this term is minus 4. And similarly, the degree of this minus 1 over z square, this is minus 2. And what is the degree of the last? That is plus 2 here. And if we want to rearrange it from lowest to smallest, of course minus 2, okay, ascending order, this would be equal to minus 4 will come first. So we are going to write the term which has degree minus 4, that is 32 over z power 4, and then minus 1 over z square. Remember, this negative sign is part of this term. So whenever you are wanting to write the term, you have to write that negative sign with it as well. And then 0 plus 81, and then plus 2, that would be plus 9 z square, and then this would be plus 4 z power 4. So this is the ascending order, And of course the descending order is exactly the opposite. Descending order is equal to 4z power 4 plus 9z square plus 81 minus 1 over z square plus 32 over z power 4. This is the descending order. And now we have the corresponding algebraic expression in descending order. Let's do a couple of more questions for finding the value of expression. And here is an example. Given that p of x, the polynomial, is given equal to 3x square plus 9x minus 1, find p of 2. Means that find the value of polynomial when x is equal to 2. And it's simply we are going to replace x with its value, and that will give us p of 2. So p of 2 is wherever x appears, replace x with 2. Here when we write 3x square, in fact 3 is multiplying with x square. Therefore we are going to write 3 times 2 power 2. So we have replaced x with 2, but we have made it clear that this 3 is multiplying with this x square. That's why we put this multiplication sign here. Plus 9 times, again 9 is multiplying with x here. There is a multiplication sign here. That's why we are using bracket to clarify that 9 is multiplying with x. Here 2 minus 1. So exponent must be calculated first. 3 times 2 power 4 is 2 power 2 is 4 plus 18 minus 1. This is equal to 12 plus 18 minus 1. 12 plus 18 is 30. Take away 1 will give us 29. So another question here. If p of x, one expression which is a rational expression here, is equal to x square minus 6x plus 5 divided by x minus 5 whenever x is not equal to 5. And there is another qx which is equal to x minus 1. These are two separate expressions. One is this p of x and the other expression is named as q of x. Show that px and qx have the same value. Show that px and qx have same value when x is equal to 2. When x is equal to 2. In fact, we are going to calculate p of 2 and q of 2. That's what we mean by that p of x and qx have the same value when x is equal to 2. Therefore, let's calculate p of 2 and q of 2. If we want to calculate p of 2, we are going to simply replace x with 2. So everything else will stay the same. So instead of x, we're going to say 2 square minus 6, because here 6 is multiplying with x. Therefore 6 times, instead of x, we're going to say 2 plus 5 over 2 minus 5. And this is equal to 2 power 2 means 4 minus 6 times 2 is 12 plus 5 over 2 minus 5 is equal to minus 3. So if we calculate it further. 4 plus 5 would be 9, and take away 12 will give us minus 3 over minus 3. This will give us equal to plus 1, because minus 3 will cancel out with minus 3. And now q of x, which was in fact equal to x minus 1, if we replace x with 2, we have 2 minus 1, which is equal to 1. So here you can see we calculated q of 2, and here you can see we calculated p of 2. P of 2 answer is plus 1, q of 2 answer is plus 1. So we can say that P of 2 is equal to Q of 2. Or in other words, just another way of saying is P of x is equal to Q of x at x equal to 2. See, we are saying the same thing, but we are using different words. So this is how we evaluate expressions. And let's do a word problem here that will further give us a better understanding. The surface area, example here, the surface area of a spherical ball, of a spherical ball, is given by S stands for the surface area, and this is given that this is equal to 4 pi r square. Find area of the ball with diameter of 10 centimeter. Find area, means surface area, of course, surface. Find surface area of ball with diameter equal to 10 centimeter. Now here we are given, and like I said already, that whenever you have a mathematical problem, you should know what we are told, or what we are given, and what is that we are required to answer. Here we know that the ball has a diameter of 10 centimeter. So if there is a ball that has a diameter of 10 centimeter, it means radius is equal to diameter. We know that radius is half of the diameter. So in fact we know that 10 over 2 is equal to 5 centimeter is the radius. Why do we need to find out radius? Because if you look in the expression, there is the value of r. There is r that appears. So we will require value of r. Pi is a constant and its value is 22 over 7. So now we can, when we have value of r, we can find the surface area. Surface area when r is equal to 5 centimeter, surface area is equal to 4 pi, and instead of r now we can substitute 5 square, that is the value of r now, 4 pi, and 5 square means 5 times 5, which is 25, and this would be mean 100 pi. So that is equal to surface area of the ball. We can write it as SA. And just the last question, we know that the temperature could be, there are two different scales to measure temperature. Temperature could be measured in Fahrenheit scale or it could be measured in centigrade scale. The interconversion for temperature scales is given by here. Example, interconversion of temperature scale is given by F equal to 9/5 centigrades plus 32. So this is in fact the formula to convert Celsius degree temperature into Fahrenheit scale. What Fahrenheit temperature corresponds to 65 degree Celsius? What Fahrenheit temperature corresponds to 65 degree Celsius. It means we are given temperature in Celsius scale. And what is that? That is 65 degree. And what is that we want? We want to find out how many Fahrenheits. So if it's simply evaluating the expression, so here C is representing the temperature in Celsius scales. So we can find out F at 65 means that what we are going to find out is 9/5. Instead of centigrades, we are going to write 65 plus 32. And if we simplify 5 one time and 5 three times, 13, 9 times 13 plus 32, that will give us the temperature. And if we want to calculate 13 times 9, 27, 2 and 11 and 117 plus 32 and plus 32, that would give us 941, that would give us 149. And this 149 is a Fahrenheit temperature. So this is how we can rearrange expressions into ascending order, descending order, and also evaluate expressions. And we have also done a couple of questions how we apply these evaluating expressions into word problems.